The air conditioning lesson will be covered in 4 sections. Let's begin with general description. The air conditioning system is used to heat, cool, and dehumidify the cockpit, cabin, cargo, and E&E compartments. The air conditioning system uses bleed air from the aircraft engines, auxiliary power unit, or a ground air cart. 2 independent packs operate in parallel to supply the air conditioning system. Each pack is composed of heat exchangers, an air cycle machine, a water separator, and an air mix valve. The pack valve allows bleed air from the left or right supply duct to enter the air conditioning pack. The primary heat exchanger operates automatically to cool bleed air entering the pack. In flight, the heat exchangers use ram air to cool the bleed air from the pneumatic system. Ram air enters through the ram inlet doors, flows over the heat exchangers, and exhausts through louvered exhaust doors. The ram inlet doors are adjustable and mechanically connected to the louvered exhaust doors. When a pack is operated on the ground or in flight with the flaps extended, a pack cooling fan operates to maintain adequate airflow over the heat exchangers. A motor-operated inlet door opens when the fan is activated. A check valve incorporated in the ram air inlet prevents air from escaping through the ram inlet. The air cycle machine, through a process of compression and expansion, provides cooled supply air to the air mix valve. The ACM compressor converts warm air from the primary heat exchanger into higher pressure, higher temperature air. The secondary heat exchanger converts the ACM compressor discharge air mixed with warm primary heat exchanger air into cool air. Operation of the secondary heat exchanger is identical to the primary heat exchanger. The ACM turbine converts cool secondary heat exchanger air into cold air by rapid expansion. Temperature sensors monitor compressor discharge temperature and turbine inlet temperature. A water separator removes condensed water from the ACM turbine discharge. An anti-ice system prevents icing in the water separator. An anti-ice valve coupled with a temperature sensor supplies warm air from the primary heat exchanger to the water separator, preventing ice formation. The air mix valve is a combination of a cold air valve, a hot air valve, and a cool air valve. These valves operate simultaneously. The cold air valve receives cold air from the ACM. The hot air valve receives hot bleed air from the pack valve. And the cool air valve receives cool air from the secondary heat exchanger. Air mix valve position determines the workload of the ACM. If cold air is required, ACM workload increases because more air must flow through the ACM turbine. If warm air is required, ACM workload decreases because more air bypasses the ACM turbine. Air leaving the air mix valves enters the air distribution system at the crossover duct. The crossover duct supplies ACM air to the cockpit and cabin. Normally, the left pack supplies a small amount of air to the cockpit, and the remaining air mixes with the right pack air in the crossover duct. Air enters the cockpit through overhead, windshield, and foot air outlets. Air enters the passenger cabin through overhead and sidewall vents. Two distribution valves adjust airflow between these vents. A Gasper system draws cold air from the left pack air mix valve and distributes it to individual outlets in the cockpit and passenger cabin. A Gasper fan augments cold air distribution from the left pack to the individual outlets within the cockpit and cabin. With the left pack off, the fan draws air from the air conditioning distribution bay. With the Gasper fan off, air to the Gasper system is available from the cockpit air conditioning duct through a restrictor valve. Ground-conditioned air may be connected directly to the crossover duct for distribution into the cockpit and passenger cabin. The air conditioning distribution system has several check valves which prevent reverse airflow. The air distribution system has several temperature sensors that supply cockpit information. They include a main supply sensor, forward and aft supply sensors, and forward and aft cabin temperature sensors. Overheat protection sensors monitor the air conditioning distribution system for excessive temperatures. They include duct temperature limit sensors, duct overheat sensors, pack trip-off sensors, and supply overheat sensors. Conditioned air leaves the passenger cabin through floor-level exhaust vents and flows around the forward and aft cargo compartments. It then exhausts overboard through a cargo heat and pressurization outflow valves. Both cargo compartments are heated and cooled by routing cabin exhaust air around the compartment walls. A cargo heat outflow valve controls the flow of air around the forward cargo compartment. In flight, with the flaps retracted, additional heating of the aft cargo compartment is automatically provided by electrically heated wall blankets. Air conditioning system controls and indicators for the captain and first officer are located on the glare shield and the captain's and first officer's instrument panels. Air conditioning system controls and indicators for the second officer are located on the upper instrument panel. Lower instrument panel and auxiliary panel. The pack switches are battery powered and control respective pack valve operation. With the pack switches off, the pack valves are closed and the air mix valves are driven to their full cold position. When air is available in the crossbleed manifold, the pack switches are moved to the on position. The pack cooling door position indicators display the position of the ram air cooling inlet and exhaust doors. The three-position pack cooling door switches control the operation of the ram air cooling inlet and louvered exhaust doors. Holding the switches to open opens the ram air cooling doors. Holding the switches to closed closes the ram air cooling doors. Releasing the switches to the center position stops ram air cooling door movement. Pack temperature indicators display the ACM compressor discharge temperature of the respective pack. The cabin temperature selectors control the position of the air mix valves in either the auto or manual mode. The control cabin temperature selector controls the position of the left air mix valve, and the passenger cabin temperature selector controls the position of the right air mix valve. With the cabin temperature selectors in auto, control and passenger cabin temperatures are selected by the second officer. The selected temperature is maintained automatically by a temperature regulator, which controls the position of the air mix valves. The air mix valve position indicators display the position of the left and right air mix valves. Selecting the detented manual mode of the cabin temperature selectors freezes the air mix valves in their last position. Air mix valve position is controlled by holding the selector in either warm or cool. An air temperature indicator displays the air temperature of selected areas in the distribution system and passenger cabin. The air temperature selector controls which temperature is displayed on the air temperature indicator. The supply positions display the forward or aft sidewall supply duct temperature. The main supply position displays the passenger cabin supply duct temperature, and the cabin positions display the ambient temperature in the respective cabin zones. With the cabin temperature selectors in the auto mode, duct temperature limit sensors in the left and right air conditioning ducts limit the respective air mix valves to a preset maximum output temperature. A control cabin temperature sensor provides feedback to the temperature regulator for automatic control of the left air mix valve. A passenger cabin temperature sensor provides feedback to the temperature regulator for automatic control of the right air mix valve. A cabin air distribution selector on some aircraft mechanically adjusts cabin airflow between the overhead and sidewall vents. Some aircraft are not equipped with a cabin air distribution selector. These aircraft have preset baffles installed in the distribution system to equalize the airflow between the vents. The Gasper fan switch controls the operation of the Gasper fan. Moving the switch to on augments the cold air from the left pack air mix valve, or pulls air from the air conditioning distribution bay, supplying it to individual outlets in the cockpit and passenger cabin. The captain's and first officer's foot and windshield air outlets are operated by control knobs. An aft cabin zone temperature system maintains an even temperature throughout the passenger cabin whenever the right pack is operating. The aft cabin zone temperature indicator is centered, the right pack temperature control is in auto, the forward cabin temperature selector is set and stabilized, The right pack air mix valve is 1/4 or more out of full cold, and the cabin air distribution selector, if installed, is in the mid to sidewall range. Two valves in the sidewall air distribution ducting direct hot air from the right pack to either the forward or aft cabin sidewall ducts. An aft cabin zone temperature valve position indicator displays the position of the two aft cabin zone valves. The aft cabin zone temperature switch controls the operation of the aft cabin zone temperature valves. Holding the switch to warmer opens the aft valve, directing hot air to the aft zone, which warms the aft cabin. Holding the switch to cooler opens the forward valve, directing hot air to the forward cabin. The passenger cabin temperature sensor senses the increasing air temperature in the forward cabin and signals the air mix valve to a cooler setting. This maintains a constant forward zone temperature while cooling the aft zone. Cargo compartment heat is supplied by air leaving the passenger cabin. A cargo heat outflow switch controls the operation of the cargo heat outflow valve. With the switch in normal, the cargo heat outflow valve is open. Placing the switch to close closes the cargo heat outflow valve, stopping airflow around the forward cargo compartment. The cargo heat outflow valve will close automatically when the pressurization outflow valve nears its full closed position. A cargo valve closed light illuminates when the cargo heat outflow valve closes. The air conditioning system has an auto-pack trip feature designed to reduce engine bleed air extraction and electrical loads in the event an engine failure occurs during takeoff or initial climb. To arm the auto-pack trip system, the aircraft must be on the ground with the inboard flaps out of the up position. All three engine EPIRs must be above 1.5, and the auto-pack trip switch must be in normal. The auto-pack trip armed light illuminates if the system is armed. After takeoff, the auto-pack trip system is disarmed automatically when the flaps are fully retracted, or by placing the auto-pack trip switch to cutout. Should an overheat occur in an ACM, the respective pack trip-off light illuminates, the pack valve closes, and the air mix valve drives to full cold. On the ground or in flight with the flaps down, the affected pack is cooled by its pack cooling fan, as long as the trip-off light is illuminated. Compressor discharge overheat verification is observed by reading the pack temperature indicator needle in the red radial. When the pack temperature drops below the overheat value, pressing the bleed air pack reset button extinguishes the pack trip-off light and restores control of the pack valve and air mix valve. If the air temperature in the main supply duct becomes excessive, a duct overheat light illuminates. With the duct overheat light illuminated, the associated air mix valve drives full cold. The overheat condition is displayed on the air temperature indicator when the air temperature selector is rotated to main supply. When the duct temperature cools below the overheat level, pressing the duct overheat reset button extinguishes the light and restores normal operation of the air mix valve. Should a duct overheat sensor or air mix valve fail, and the air temperature continues to rise above the duct overheat value, the associated duct overheat and pack trip-off lights illuminate, the associated pack valve closes, and the air mix valve drives full cold. Selecting main supply with the air temp selector displays an off-scale indication on the air temp indicator. When duct temperature drops below the overheat value, the bleed air pack reset button is pressed, extinguishing the pack trip light, restoring pack operation. Pressing the duct overheat reset button extinguishes the duct overheat light, restoring air mix valve operation. If the temperature in the forward or aft sidewall distribution ducting becomes excessive, the aft cabin zone overheat light illuminates and the open zone valve closes. With the light illuminated, both valves are prevented from opening. When the temperature in the supply duct cools, the aft cabin zone overheat light extinguishes and control of the system is restored. During takeoff or initial climb with the auto pack trip system armed, a loss of thrust on any engine causes the engine fail and pack trip-off lights to illuminate, closes both pack valves, and interrupts power to the pack cooling fans, preventing their operation. The engine fail lights are canceled by pressing either light. The pack trip-off lights are reset by pressing the bleed air pack reset button. Pack operation may now be restored. Placing the auto pack trip switch to cut out or pressing the bleed air pack reset button prior to placing the pack switches off may result in a generator overload due to pack fan reactivation. On the Dash 247 aircraft, the pack cooling door switches have a center auto position, which has been deactivated.